Hello, my math friends. This is Mrs. Schlecht, and in this video, we're going to generate some equivalent expressions. All right, my friends, you know that there's a few materials you need in order to be successful for this activity. First, you're going to need your Envision book. That's the one with our robot friend on the front. Second, you're going to need your math notebook to take those beautiful, most amazing, fantastical notes. Third, you're going to need a pencil to take those notes. And fourth, last but never, ever least, that positive math attitude. Okay, so this video goes really well with lesson 3-6 that is in your Envision book. And the key concepts page that we're going to check out is page 164. Okay, my friends. So like I said, we're going to be creating equivalent expressions, right? So what that means is we are trying to make different expressions that are equal to each other. And the reason that we can do that is because there are certain properties, certain rules that we have in math that allows us to play around with these numbers and make them work for you. So if you check out that key concepts page, you'll notice that there's 3 different properties of operations that it's talking about. And you want to know what? We're going to talk about that now. All right, so the first property we're going to talk about is the commutative property. Now, you might not remember the word, but you have heard about it before. Now, this is a property that it's only in multiplication or addition. That's it. And basically what this means is that I can multiply, I can add in any order, and I'm going to get the same answer, the same value. This is what I mean. So let's look at this simple example. We know, we've been adding since like first grade, right? That 3 plus 5 equals 8. But we also know that 5 plus 3 also equals 8. Why? Because of the commutative property, my friends. That means that I can add these in any order and I'm still going to get 8. It also works with multiplication. So here we have the same numbers, right? 3, 5, 3, 5, but now we're multiplying instead of adding. But with the commutative property, I still know that it doesn't matter which order I multiply these in, I'm still going to get 15. 3 times 5 is 15, just like 5 times 3 is 15. So remember, this commutative property, what it means is that you can add or multiply in any order, and as long as you're still adding all the numbers or you're still multiplying all those factors, you're going to get the same answer. All right, so property number 2 is the associative property, and also this goes with multiplication or addition. And what it means is if I am multiplying or adding 3 or more numbers together, it doesn't really matter how I group them or how I multiply or add them, I'm still going to get the same answer. This is what that means. So if we look at this first example, we have 3 plus 5 plus 10. Now, if we do the math, we know that 3 plus 5 is 8, plus 10 is 18, right? So this expression is equivalent or equal to 18. But what if I use some grouping symbols? Is that going to change the outcome? All right, so now I've added parentheses around our first 2 terms, right? 3 and 5. So now I'm going to have to do the parentheses first, orders of operations. Let's see, that's 8, and then 8 plus 10. Hey, that's still 18. What if I move these parentheses around? Is that going to change? So it won't change our value, right? Because if I do my parentheses first, which order of operations tells me I need to, we still have 5 plus 10, which will give us that 15, and then we add 3, which again gives us 18. Does this work with multiplication? Let's check it out. So I've just rewritten same numbers, but now multiplication instead of addition. And let's see if it works. So if we do 3 times 5, that's 15. 15 times 10 is 150. Will it matter the way that I actually multiply this? So now same expression, but I added those parentheses. So we need to do this piece first. 3 times 5, still 15. And then I have to multiply it by 10, and that's still 150. So that works. What if I move these parentheses around again? So now that I have the parentheses towards the end of my expression, I'll do this piece of my multiplication first. I'll do 5 times 10, which is 50, and then multiply that by 3, which again gives us 150. So the associative property, my friends, basically means when you're adding a bunch of numbers together or you're multiplying a bunch of numbers together, it doesn't really matter how you group them or how you choose to tackle that big problem. As long as you're still multiplying all those numbers, or as long as you're still adding all of those numbers, your value is going to stay the same. Right, and the last property that we're going to talk about for this lesson is the distributive property. That might also sound familiar, hopefully, because you talked about it in 5th grade. Now, what I like to think about with this distributive property is the word distribute. If we distribute something, we're like passing something out, right? So keep that in mind while we look at this next example. All right, my friends, so in this example, we're using parentheses to group a certain amount, right? This 6 plus 3. And then like we talked about when we were first getting into like pre-algebra, whenever you have parentheses and then just a number next to it, that means multiplication. So what this actually shows us is I'm going to first do 6 plus 3, and then whatever that answer is, then I'm multiplying it by 2. Now, okay, we will use the distributive property. What that means is I'm going to pass this 2 along, right? So this means multiplication, right? When we just have those parentheses and then like the number next to it, that's multiplying, right? That's addition there in the center. But what distributive property tells me, my friends, is that I can do 2 times 6 plus 2 times 3, and I should get the same answer. So let's see if that's true. So first, if we solve this part, we know that that is 9 because 6 plus 3, that's 9. 9 times 2, that's 18. So in theory, if we use this distributive property, I should still get 18 as my answer. All right, so now my friends, I've distributed that 2, and I've used these arrows here to show you that that's like the 2 that I'm like distributing, the 2 that I'm passing around, right? So I first distribute my 2 with that 6, so I do 2 times 6. Notice that I kept an addition sign here because that was the same side that was inside that parentheses, all right? If this was subtraction, then it would be subtraction down here, right? I added multiplication again because this right here is representing multiplication, but again, this sign is the same as right here because I got to keep the same value, right? They're still equivalent expressions. And then I distributed that I distributed the 2 with the 3 as well, and that got us 2 times 3. So now, my friends, instead of just having one parentheses, right, and then multiplying it by 2, we have 2 different groups. But will it still equal 18? Yeah, it will, because 2 times 6, that's 12. 2 times 3, that's 6. What's 6 plus 12? 18. Okay, so remember, that was just a quick run through over those properties of operations. And those are the rules, my friends, that we are using to be able to create all these other equivalent expressions, right? That's like the reason why this math works, why we're able to like move these numbers around, right? So now let's actually start putting this into practice, my friends. Let's look at page 164, number 8. Okay, so for number 8, what we have is one complete algebraic expression, but we're trying to make that equivalent expression as well, all right? And we're going to use that distributive property to help us out with this, all right? So you'll notice that we have 8t coefficient variable, just, plus 2, right? And I'm trying to see what that's equal to. So I'm going to take a 2 and I'm distributing it to everything that's inside my parentheses, right? And I have to get 8t plus 2 as my outcome. So let's think real quick. I have 2. 2 times what would give me 8t? Well, let's see. If I know my 2 times tables facts, which you should, I know that 2 times 4 would give me 8, and that's what is missing right here. Now, notice that we still have this variable here, but the variable isn't changing, my friends, because that's our unknown at this point, right? So we are trying to figure out what the coefficient would be, correct? And so since we know that the original coefficient was 8, but I'm going to divide that by 2, so to speak, our new coefficient is 4. And we can test this out too, my friends, because if I distributed that 2, well, what's 2 times 4t? Well, then I'm going to have 8 times t as well, right? Let's look at this last piece. If my last number is a 2, then think to yourself, well, what do I need to multiply 2 by in order to get 2 as my final answer over here? Well, I don't know about you, but I'm pretty sure that when you multiply a number by 1, you're going to get itself, right? So 2 times what would give me 2? Oh, that's right, 1. So congratulations, my friends. You just completed your first equivalent algebraic expression. Way to go for you. What we did was we started over here with 8t plus 2. We knew that we could use that distributive property to help us generate an equivalent expression to that. And I pulled out that 2, right? Now, if I distribute that 2, let's just double check. Well, 2 times 4t, that would be 18. Oh, 8t, check, right? And then 2 times 1, that would be 2. Check on that one. So pretty nifty distributive property. Now let's look at page 165, number 11. Right, so for number 11 on page 165, we're still going to take advantage of that distributive property to help us figure this one out. So we start over here, right? We have 3. And then I know that this means multiplication, right? So inside the parentheses, we have m plus 3. Now, I don't know what m is, so I'm just going to leave it as m because I don't got enough information for that, right? But now the question is, well, then how do I go from this to this, right? Well, let's think. Remember, we're going to distribute or pass around that 3. So that 3 will be multiplied by m, and then it will be added to whatever 3 times 3 is. So what would that actually look like? Friends, it would look like this, right? Again, if we distribute that 3, we have 3 times m, which I can represent by 3m, plus, keeping that same operation sign, 3 times my whole number, which is 9. So my friends, you just created another equivalent algebraic expression, right? So cool. We know that 3 times m plus 3 is equivalent or equal to 3m plus 9. Let's look at one more. Let's look at page 165, number 12. All right, my friends. So again, this is page 165, number 12. One thing I wanted to make sure that you noticed is that we have 2 different variables in this expression, correct? We have n and we have m. They're not equal to each other, okay? If they were equal to each other, they'd have the same letter. But since we have 2 separate variables, we know that they have 2 separate values. Therefore, my friends, we can't just combine it. We can't just say, oh, it's 16n. Nope, can't do that because these have different values, so you can't just combine those like terms, okay? And that's reflected by, if we look at what our answer will be, notice we still have an n and we still have an m, right? Those ones still need to be there because if you take them out, you're going to change the entire value, all right? So keep that in mind, my friends. Now, look, we have 20n minus 4m. And when I'm getting ready for that distributive property, I notice that they pulled out a 4, okay? So now I need to kind of backtrack a little bit. Let's look at n, okay? 20 is the coefficient with n, right? But now I already have a 4. So think to yourself, well, 4 times what would give me 20? 5, you know that, right? I know that 4 times 5 is 20, so it only makes sense that then if I did 4 times 5n, that answer would be the same or equivalent as 20n. Let's look at this last piece. Notice that I kept that same subtraction sign because that piece doesn't change, my friends, right? But now let's look at this 4, right? What do I need to multiply 4 by to get 4? It's just 1. You know that. So if I were to distribute this 4 for this second part of our expression, we know that we would do 4 times 5n, which, hey, would give us 20n. And then we'd also distribute this 4 with 1m, which would also give us 4m. Way to go. All right, my friends, so that's how we can create some equivalent expressions. Super cool. If you have any further questions after watching this video, please let me know.